Uh, Welcome friends. Now we are just trying to go for this video to make a little correction. In the last videos, while deriving the expression for coefficient of pressure across a shock, we made little mistake there, especially in the coefficient. So I'm just going to correct this right now. Procedure was same, but I saw later on that the numerical value we didn't change; it remained as it is. While doing the manipulation, it should have changed. So now I'm going to just derive this equation again, and this time we'll have the correct evaluation. Now the pressure coefficient goes this way. We have CPs. The CP definition basically is given like this, and this is CP definition irrespective of the type of the flow and irrespective of the situation or any kind of other location. So this is CP in all the situation. This definition is free from any situation, and this Q1 and P1 are basically the reference situation. So Q1 is just at the first location, so it's a dynamic pressure, the first location, and static pressure, the first location, and P2 is basically the static pressure at the second location. Now this Q1 and Q2 in the normal cases are taken as the free stream conditions. So in that case we can use that as a Q infinity and the P infinity, and P2 is actually the location or the point where CP is being evaluated or calculated. So as a matter of fact, we can, in this particular expression, we can also call it CP2, and this is our Q. This Q is nothing but the same Q from here we have taken, and we just try to manipulate it and try to find and express the Q in the form of Mach number. So the Q is either 1 by 2 rho 1 V1 square or 1 by 2 rho P1 M1 square, and we can simply see that how we have done it. It's just we have just tried to divide and multiply by rho gamma that is gamma P1 by gamma P1, and then this V1 square by gamma P1 by rho 1 becomes actually M1 square, because this gamma P1 by rho 1 is actually M1, the Mach number. This is actually the speed of sound. So V actually square of speed of sound at the location 1 or the reference location. So V1 square divided by A1 square is actually M1 square, and then this whole thing becomes actually 1 by 2 gamma P1 M1 square. Now in manipulating the coefficient of pressure, we can actually simply write it like this: P1 by P2 by P1 minus 1, and then his whole thing goes there, because this P1 has been divided over here, so E1 is we are multiplying also, and below this Q1 we are writing in the form of Mach number. So 1 by 2 gamma P1 M1 square is coming below, and P1 is here. Now simply just this 2 goes there, and this P1 and P1 cancel each other, so it becomes like this. Now after putting this P1 and P2 by P1 ratio across the shock wave, we get it like this. So we have not done any manipulation. Simply, actually, we have not assumed anything. We are simply putting this value from here to here is as a matter of fact the pressure ratio across the shock, and this minus 1 is still here. So once this minus 1 cancels here, we become actually 4 by gamma plus 1. This is manipulation. This 2 goes this 2, and then become 4. This gamma cancels this gamma, so gamma is cancelling. Gamma plus 1 remains there. This M1 square goes here, so it cancels M1 square. So sin square beta minus 1 by Mn square. It should be noticed here that till now we have not assumed any of the assumption. Normally we have been doing the assumption in the case of hypersonic flow that the Mach number is very large, or in the case of low angle flow, we call it beta is very low, wave angle very low. Till now we have not made any such assumption. Now we are going to make the assumption and trying to modify it. This is the outcome. This is the outcome with the exact value, exact expression. Now this is the same thing. We apply Mach number tends to infinity, so that's what we are doing for the sake of hypersonic flow. So this value becomes 0, and then we finally have got is actually 4 pi gamma plus 1 sine square beta. We have not applied the assumption of a low angle, so sine square beta remains sine square beta. And if you just recall the mistake we made earlier is this 4 remained 2 actually. This 4 should have been 4, but it remained 2. So there's only mistake we made there last time when you derived this expression. So we have corrected it now. We can now go ahead. You should also make sure that in your notes it's also corrected, so that you will not make any mistake when you write the examination and solve the cases. Thank you very much.